So the equation was that way. Okay, it's like both have numbers. They say that 350 million people are missing right now. I don't think it's like numbers.
Okay. Yes, you're okay back there? Can you guys hear okay back there? Whoa. All right, hold on. Test. Still bad. Is your mic muted on yours? Can you mute your mic? Sure. And we'll pick up off of your. Test. Is that better? Well, I'm not sure how we're going to get audio. How we're going to get audio on the Hangout. Mute the computer that's using Hangout. It is. Oh, it is. This one? That one's not. You can mute that one. Okay. No, it is. Okay. All right, there we go. All right. Put two mics on. Try it now.
Oh, is it because you had two both going?
Yeah.
I was
Two
say,
Hangouts doing mics.
Right.
Okay.
I was going to say if you open it.
Still doing. Is it this one?
Is this mic on?
Nope. That computer's mic is on. If you stop that one,
I thought that was. I think we just.
it's like a Led Zeppelin concert.
Ladies and gentlemen.
Sorry.
See, that one's muted.
Interesting.
I wonder if it's getting feedback from the input from itself.
Check. Better. It's still kind of echoey. I think you're using our mini, right?
Yeah.
I think what's happening is, see, normally we use this with GoToMeeting. It's using this as the input, and the output is going to the speakers. Normally, it just sort of goes right in there, and it's not looping.
Oh, like the output device.
Tell you what, for the built-in output, let's try this. Check. Check. Check 1, 2. It is. I haven't used it with Google Hangouts before. Sorry, man.
Oh, good.
Is there anybody else in this room that has this Google Hangout up that might be looping through?
Does anybody else have the Google Hangout up by chance? If you could close it out, mute your computer. Whisper closely to your computer, just in case.
It's a Hangout on there. There's only 3 people in it.
Yeah.
It's only these 3 people in it.
It's not my fault.
Yeah.
Let me make sure this is not muted.
Yeah.
Mute.
Check. Still echoey.
Turn the microphone on this and turn the microphone off on that.
There you go. Awesome. Okay, so anyway, all right. So as I mentioned, you get a lot of code reuse because the code that actually like generates whatever you need generated can be reused across a bunch of different models. You also get a better separation of business logic and implementation because in this diagram here, you can see that they have whatever models that you're actually using, and then some sort of generators that generate the actual like XML maybe, or the analysis tools, or maybe C or C++ code. So you can get really creative with these kind of things. An example of one of the use cases for some of these is that Vanderbilt, because Vanderbilt got a grant from I think DARPA, which was part of the AVM or the Amphibious Vehicle Make Challenge. So basically what they were doing was building an open source tool suite using domain-specific modeling, or using model-integrated computing, to allow people to model things like vehicles. So like you would just say things like where the transmission goes and how it connects to everything else. And then they actually hooked into a database of all the components that would go into this vehicle. In other words, like actual transmissions and all the specs. It would pull all the information from there and then tell them that they can make like, I don't know, 10,000 or something possible combinations of vehicles given all the parts that they have, and the model which diagrammed how those parts would work together. And then from all of those parts, they would go through and check like which ones were actually compatible, maybe get like 100. They would pick maybe 10 that they wanted to simulate. And then their modeling environment actually hooked into a physics simulation engine. I want to say Mathematica, but don't quote me on it. I saw the demo like 2 years ago, so this is an exercise in memory, not an exercise in good jokes. Anyway, so they were able to hook it into a physics engine and actually get information like how long it would take to get from 0 to 60, and not just 0 to 60, but 0 to 60 in the sand and 0 to 60 in water, because basically if you can model it or you can have some way of representing this with physics, they could get all of the data that they needed from the model and the components that they were pulling from online. So the nice thing about this is that if the components change, you actually don't even need to change your model. You can make the same vehicle with new transmissions and new parts without actually going through and changing all of your code because everything's like loosely coupled. And another thing that it does is when you're modeling, a lot of times the barrier to entry is a lot lower, especially for domain experts, because a lot of times you can capture things in visual programming, like capture intuition and such that you can't capture when you're using just text. All right. So I have some examples here. Has everyone heard of Project Ara? So Project Ara, has anyone heard? Well, I should probably have people raise their hands because I don't want to explain something if everyone knows it. So Project Ara, phone blocks. Okay. So Project Ara is Project Ara is a project from Google that's trying to make a modular smartphone. So they provide like a skeleton of a phone with like Lego-like holes in it, so you can just put these electrical components actually in it. So let's say you were going on a long hike and you didn't want to take pictures because you just weren't feeling photogenic that day. And then you could actually pull out the camera and add in like another battery. And you wouldn't actually need to be like an expert in working on phones because it's a really simple way to do this. Now, there's actually a startup in town here that's working on the developer tools for Project Ara. So basically how people can make the mechanical components to go in this, because obviously there are a lot of size constraints, especially when you're trying to accept components from all sorts of different areas. So they're using this concept of model integrated computing, and actually this is like all powered by the WebGME to do things that are, again, meaningful to people in this space. But like you can see that they have like an Arduino interface, some general purpose input-output stuff, analog breakout, either way, electrical-y things. Hopefully no one feels insulted when I just gloss over those things. Just if I go in more detail, you'll realize how much I don't know about it. So, anyway, so now we've discussed a little bit about model integrated computing. Basically, it lets you put the model at the heart of what you're doing so you can lower the barrier to entry as well as make these things, is decouple your business logic so you can have all sorts of implementation under the hood, but the people who are actually using it don't need to worry about it. And of course, upgrading to like a new tool or changing the back end is really easy because you actually don't need to go through like a 100,000 line code base. You just need to go to a little generator that converts it. It does all the conversions and change how it does the conversions. Now I'm going to discuss WebGME. Now, I mentioned before that these are like that there's this concept of domain-specific modeling languages. So that's the idea that you have some visual programming language, be it boxes and lines, or things like connecting to each other, or Zoom, or however people want to get creative with like D3. And there's the WebGME is a platform that lets you actually that provides a generic modeling environment. So basically, before you actually have the domain-specific modeling parts, so like maybe if you're doing electrical stuff, you might have a box that represents a circuit and connections that represent how the energy or the electricity is going to flow from circuit to circuit. The WebGME gives you actually a language to define modeling languages. Now, it's pretty meta with some of these things, and that's actually called the Metamodel, but we'll get into that in a minute. But I'm going to try to keep a running example. I'm going to try to keep a running example so that we can see, so it's easier to put something concrete to these goofy things that I'm talking about. These things can get pretty meta. Like, it gets weird. Anyway, so those of you who, well, okay, so I probably should see whether this is even a relevant example first. And did anyone play like Zelda? N64? Oh yeah. Ocarina of Time? Awesome, fantastic. Okay, so if you remember in Ocarina of Time, for any of those who like didn't have a childhood, in Ocarina of Time, like they give you all these like items, and you need some items to get other items. So like the plot line progresses by you solving puzzles and getting these things, which enable you to get other items and so on and so forth. Now this picture in the bottom center here is actually the big Goron sword. It's fantastic. You just walk around, you take people out with like one hit. It's fantastic. I love it. Anyway, so but the thing is with the big Goron sword is when I was a kid, I was always like, how do I get this? Like because you need all these different items to be able to put it together and figure out weird plot lines, and I just wanted to get to like smashing things. So if you go online, you can actually find this dependency graph, which tells from the beginning of the game in the top there, which says start, and every line represents basically the dependency. So as you see here, it says start. Then after you start, you can get the Kokiri sword and the Deku shield. After you get those, or both of those are required to get either of these two beneath that. So basically, if I wanted to get the Master Sword, I need the Song of Time, the Ocarina of Time, and I just have to keep walking backwards in this graph. Man, it's pretty tough to figure those things out when I was a kid. Third grade me, I was like, man, I just want a sword. It was crazy. Anyway, so now we're going to get into the model and metamodel. So the metamodel, like I said, is a language. It's actually a visual language that uses a UML-like syntax to define your modeling language. So you're given a modeling language, again, which is like UML, to define other modeling languages. So essentially, we're answering questions like, what kind of things are we representing in this model? What do associations between those mean, and stuff like that. I have an example here on the right. In this example, you can see I have a house object. These boxes represent essentially like objects in your model. So we have a house, and a dog, a person, and a border collie. This, for those of you familiar with UML, a lot of these should look familiar. This red line that has a triangle on one end, and then from the dog to the border collie represents inheritance. So basically saying that border collie is a type of dog. In attributes here, we have, again, attribute set. So here, a dog has an associated age, which is an integer. And then this blue line means a reference or like a pointer. So this dog has an owner reference, which points to a person. So the dog is owned by some person. And then these black lines with the diamonds on one end mean containment. So a house contains a dog and a person. So when we put all of this together, it means that a house can contain dogs and people, and every dog can have an associated owner, and border collies are a type of dogs. I might be a little biased personally because my dog is a border collie. I suspect that although it wasn't intentional, there might have been some like subconscious things going on here. Huh. I'm happy I put the owner reference in there because it would have, like Freud would have really had a field day if I was deleting that. Anyway. So now let's jump to our example. So as I mentioned before, our example here is going to be The Legend of Zelda. So it's going to be The Legend of Zelda where we have this dependency, or it's going to be the dependency graph. So we have items, and then certain ones are required. Disregard this error. It'll probably start. It won't start. Anyway, so I'll get back to this in a minute. This is what happens when you are scrambling for a different computer and stuff. Anyway, so I can do it this way, but I don't want to do it this way. This is going to be lame. Okay. Does everyone know their neighbor? If you don't, you should introduce yourself quickly, and I will just wait for you to introduce yourselves. Oh. I was hoping that was subtle. I was hoping I was being subtle. Oh my goodness, what? No, that's true. Ooh, good shit. So I just made this yesterday, so the version should be good, hopefully. But hopefully. Oh yeah, that's right. I'll double check if this doesn't work. I'll cross my fingers for this one. Because I can just show the Metamodel, because I took pictures of everything, so I wouldn't have to do a live demo, but I really want to do it as a live demo. Because it's kind of lame to just be like, trust me. Post install. I don't think this will work. Okay. There's almost always a workaround. I will find it. Yeah. I'm the other way. Command line on Windows, I'm like, just back away slowly. Yeah. Yeah. I'm more of a Linux guy, but it's similar on the command line, so I can usually jump back and forth with that part well. With the graphical interface, I usually suck. I'll make it work. How to try to fix it when you're presenting and then things aren't working and you just have to troubleshoot on the fly. I could be like, let's talk about NPMs. So close. So close.
So I think I'm actually using an older version. I think I'm using 1.2, and I thought 1.3 releases last month.
What's that? Almost there. Almost. Oh. Oh. Yeah, I forgot about starting this guy.
Yeah, no worries.
All right. I think we should be good. 1 second, let me make sure.
Open up the page and we'll
Yeah.
getting something.
Yeah, who needs those errors?
Cool.
All right. Hopefully everyone learned their neighbor well. I like to promote community. I also like to promote listening. Anyway, the people who didn't get that joke just feel so left out, I'm sure. Especially those who were talking.
Everybody, start back up.
I was hoping that would work. I know I actually did my undergrad in math and education, and they would tell you to flip the light switch. I didn't see any light switches, so I figured whistling into the mic was the next best thing. All right, so now we have the WebGME started here. we can when you start, you have to first make a project. So I'm just going to make that one, and I'm going to start it from just an empty seat so you can see how we work from the beginning. So when you start a project in the WebGME, you're given nothing but an FCO. FCO stands for first class object, fancy talk for thing. And now once you, so like I said before, when the Metamodel is a model that defines a model, or a modeling language. So so what you do here is you're actually going to define all of the things that we'll need in our domain. So as I mentioned before, our domain is like a dependency graph. So basically we have stuff and things, and then some way to show that that stuff depends on other stuff. So we can represent that here by saying, well, we're going to have some sort of graph first that's going to contain these guys. Make it bigger? Sure. There we are. So essentially here, well, we have stuff, and then we have a relationship called, let's say depends on, just to really, I don't know, stick with what I was saying before. And then we have to have something that holds all this. So like, let's call it a graph. All right, and now we have to get to using those relationships that I referenced before. Ignore those big pop-ups. Who needs them? Now, you should see that in our actual model here, it created these objects. So it uses prototypical inheritance. I'm not going to get into this too much, but essentially that doesn't draw a really hard distinction between classes and instances, just like how JavaScript works essentially. Anyway, so once we have these objects, we can define relationships. So we start with this black one, that means contained. We can say that stuff is contained in the graph. So if I drag this to right there, we should be seeing things. I'm just doing like the worst presentation. Okay, we're going to jump over. So we have stuff. All done. And then we have some relationship that's saying the dependency required for or it depends on. And then we have a container that holds all of this. And this basically defines the nodes that are going to be used in our Metamodel. And we can see if we go back to this dependency graph, the kind of thing that we want to represent at the end, we have all these nodes here would be our of type stuff or item. And then these lines would represent dependency between all of these. And then, of course, this whole thing would be considered a graph or dependency graph. All right, so after we get into the model, we can actually step into it to make that dependency graph like I just showed you. So this model, again, like I said, it represents like instances, so actual elements in the domain. And you can instantiate these elements defined in the meta model. Now, I'm going to test and see if I have any more luck. Versions can kind of kill you if you're not careful, especially when you switch laptops right before your presentation. In general, I wouldn't recommend it. In case people are wondering about like what would make a good presentation, it's not one of them. All right. So now if we try this already populated one, I think I have problems remnant from my installation thing because I did a goofy hack to try to get around it. It's almost like goofy hacks weren't meant to work. Anyway, so if we can zoom in, we can see a screenshot of the model that I took before I came, just in case bad things happen. Nice. Thanks. So although I didn't zoom in quite as much as I'd like, we have the Kokiri sword, the Deku shield here, a slingshot, all the items that I was referring to before, and ending with my what I aspired to as a child, get the big Goron sword. All right, so that's basically how you can actually define these models and create them. But being able to create a model doesn't do you a whole lot of good if you can't actually generate something meaningful from it, because all the stuff I've showed you up to this point is a slightly more, could be seen as like a slightly more structured version of any of those diagramming tools online, like Lucid Charts. So that's where these plugins, add-ons, and executors come in. So a plugin is code that can be executed with access to a model. So these are actually JavaScript components that can write or read to a certain model. And they're actually user-triggered. So this is when you actually say, like, oh, I want to actually, it's like hitting the compile button, essentially. Now, these can do basically whatever you want. If I can get my example working, it generates Prolog code, which will tell you what dependencies are needed for any item that you want. I'm going to be pretty bummed if my example doesn't work. All the time I spent on that yesterday. Anyway. So I'm going to give this one more shot here, because I'm having some sort of version issue. Oh, there we are. So if we jump into the Ocarina of Time, you can see that diagram that I had a screenshot of before. All right, so I'm actually going to just get through the rest of the slides and then probably come back to this to see if I can get going, because I don't want to waste any people's time sitting here. Is anyone on board with that? Raise your hand. Sounds good. Okay, so the next concept that we have is add-ons. These are code that can be, that's actually event-driven, so it gets triggered whenever an update happens on the model. So this would be something like, you can imagine it as being the textual equivalent of like things like code completion almost, or like checking for errors in the model and giving you visual feedback. Only one instance for each add-on runs per project. That's referring to the fact that these are actually run on the server. The plugins can be executed on the client or the server. I'm not going to get into too many of the fine points there. I do have an example of that too, but we'll just wait for now. The next thing is another, it does contain some throwback references to my childhood as well. For those of you who were Pokemon fans back when it was cool, this is execute. See what I did there? Maybe. Anyway, so executors. These are actually an infrastructure for delegating computation to slave machines. So when I referenced before, so add-ons and plugins are both executed either on the server or on the browser or on the client. But that means that you're going to be working within the browser. Not everything that you want to do works from within the browser. If you remember back to one of my earlier slides, I was referencing things like Simulink and Mathematica and stuff like that. Well, executors actually give you access to like running like C code or getting access to GPUs if you really need to do some number crunching. And these are used within the context of other components like plugins or add-ons. Here's just a basic diagram of what I was saying. The WebGME actually maintains a job queue, and then you can have as many executors as you want that will query the job queue and pick up jobs as they become available. So this lets you basically delegate computation out horizontally. The last thing I'm going to discuss is visualizers and decorators. Man, I feel like this presentation was going to be so much cooler when I was like, guys, check all this stuff out. Go to Prolog. Anyway, man, you guys are unresponsive. You guys say things that you just don't say in presentations, and then you guys are just like, huh. I'm just not sure where I can go from there. Not giving me much to work off of, but it's okay. I heard a couple chuckles, so that'll get me through these last few. All right, so visualizers. Visualizers I actually provide custom data visualization. So as as you saw from probably most of the screenshots, unfortunately, not as much of the live demo, the data is usually visualized with boxes and lines. So you'll have like a flow chart looking thing like you saw in my dependency graph. But it's you can actually write your own custom ones that interpret the metamodel or the data model underlying all of this in different ways. So for example, this is a screenshot actually from the WebGME where I created a visual programming language to write constraints. That's a problem for another thing. You can write constraints on the model, which will actually go through and make sure that your model's well formed. Like for example, if you're making a flow chart that should only have one start node, you can say, all right, I have a constraint that specifies that this only has one start node, and it'll go through and evaluate your model to make sure it's all well formed. But so this is a visual programming language, actually a screenshot of one, where I use the WebGME to define the syntax of this language in the metamodel, and then I was able to step into it and create this constraint or this code, and then I had a plugin that would actually compile this into JavaScript that was actually executed asynchronously because it was doing a lot of network requests, so I was doing all sorts of funny compilation tricks to make sure I didn't like Stack Overflow and loops, and it's a whole mess. If you guys are curious, I presented a paper on this in Pittsburgh a couple weeks ago at like Splash conference. Either way. Another visualization concept that we have in the WebGME is decorators. Now decorators, as it says here, they control the visualization of each node. So if you want, so in my example, I just had those kind of gray square boxes, but you can actually have them look like whatever you want, and you can make your own logic that that'll control how you want it to be visualized. If you want it to be a circle that just grows when you hover over it and then explodes when you click, you can do that. Not sure why, but you can do that.
There's a use case for that, actually.
What's a use case for decorators?
There actually is.
Oh yeah, there are plenty of use cases. Yeah.
If you in your previous slide, you talk about like a violation, you could then make you could actually like not allow an invalid model to even make a catch.
Yep, and they actually have like 5 decorators built into the core project, including like SVG decorators. So if you want any custom SVG, you just apply that, and it'll show it on the screen. The default decorator actually supports ports, so you can have children that can be visible through the parent, and then you can like connect things to them. So that decorator actually looks at that node's children and then adds them as they get created. There are a couple other concepts that I didn't touch a lot on in this talk because I tried to get through all the components that go into this. But the WebGME also supports collaborative editing, like Google Docs style editing, as well as version control. I might actually be able to show you some version control here, but it might be boring because I just started this project. Yeah, this is a pretty boring history. Anyway, if I had done more things, you would see a list of all the commits, and then you have branches, so you can fork and merge and all those fun, What's that? So the thing is it's a little different because Git actually is looking at like text files. So its primitives that it just talks about are whether or not a line was added or deleted. So because even when you change a line, it says it's a delete and an add. But in a visual environment, it's not the same because your primitives are like, well, this object was moved, or this object was deleted or renamed, or so like, because when you're writing a text file, you just have. Yes.
So that's curious because the closest analogy I have to this is GNU Radio Companion, which is the exact same kind of visual interface. At the end of the day, that's an XML file. And so you can version that with Git. So you're saying this is not backed by some kind of file at the end of the day, or is it a binary representation?
All right, so if you're curious, we can get into the data model. So in order to promote scalability, so one of the reasons why the WebGME was created, so to give a little bit of history here, the WebGME had a predecessor called the GME, who'd have thought, that ran locally on like a Windows machine. The reasons why they actually moved to the GME the WebGME was because there were some problems with the GME in terms of scale. So they had people, I believe at Ford, they had people who were really interested in this ability to be able to prototype cars and get things like 0 to 60 and safety test results without actually touching a component or touching a piece of hardware, because that saves on cost so much. And especially when you can add things, when you have things available like version control and such, it's really appealing as a whole development environment that's really inexpensive and you can iterate quickly on. So that's so one of the problems that they had. So that's why those like Ford and those auto companies can get really interested in this. It's not just auto companies. I actually have a side project that I might talk about in a little bit, depending upon versions and stuff. Anyway, that's using the WebGME to provide a development environment for deep learning, specifically like convolutional neural networks and image recognition type of things. Because I like to lower the barrier to entry, so you can't do it wrong. You can do it bad, but not wrong. But anyway, so one of the problems that they had with the GME was the fact that it didn't scale because you need to load the whole data model into memory, and you're on just one single machine. So that's a big reason why it became web-based, as well as, of course, collaboration and such. So this isn't the presentation I was going to be presenting here, so I'm going to skip through some of these slides. If you guys are curious, there is a link to this, and I can give you a link to this whole project. And then you can actually play with my example without like me just pointing at it and having screenshots and talking, listening to crickets, that kind of stuff. Anyway, so the data model gets really interesting because they try to, so in order to promote things like scale, for example, your browser actually only loads as much of the project as it needs to see. So one thing I didn't discuss in the visualizer was your visualizer contains what they call a territory, which says, given the node that you're looking at, how much of, like, how deep do I need to look, and like what nodes am I interested in? So then it'll load only the things that are in its territory, and it'll only receive updates on things within that territory. So this helps scale because if you have a model with like 10,000 components, no, 30,000. How many do you have? So like for example, if you're doing something, say theoretically, with like TinyOS and microcontrollers and stuff, wait, no, medical capture robotics, sorry, not microcontrollers. Anyway, you might have a model with 120, I think, 1,000 nodes, which would not be practical and like if you had to load all of those into memory, or especially not at one time. So the WebGME provides a custom like data model where they try to do like a minimal amount of loading. So let's see here. So in short, it gets kind of complicated. If you guys want me, how much detail do you guys want to hear? Put your hand up for a ton, down for less, down for less. I think you get the point. Okay, so medium low. We got some hands that didn't even come up. Man, those people must be upset. This guy just keeps talking. Anyway, so there's a lot of information about the details behind here. Essentially, it has its own data model, which was trying to be as lightweight as possible to promote scale. So like when you like copy a node or a whole subtree with respect to containment in the model, it actually it maintains a reference to the original things and only lazily creates the nodes as you edit them.
But at the end of the day, are we talking text or are we talking binary?
It's still text. It's sort of Mongo right now. You could put it anywhere else, but or you could put it in other things.
So
but
in
yeah.
principle, you could shove this into Git.
Yes, the problem you could shove it into Git, but the problem is like some things get a little trickier in terms of like handling like merge or not. Let's say I'm trying to think of merge conflicts.
Or even in terms of like something like IPython notebook kind of style where we export it out and the results are shareable, predictable.
I'm not. I can see a lot of application for this. I'm just not excited about having multiple different types of revision control. If I'm already in Git, then I'd like to kind of stay there.
Here, if you want to see what the data model looks, or what the data looks like for the example,
yeah,
I can do that. Oh.
Not that internet radio is the end-all and be-all, but at the end of the day, it's just an XML file.
Yeah.
All the visual stuff, and it's a really simple schematic that I can actually move back and forth with JSON. And this is this might actually be, because the machine learning is exactly what I was going to appropriate the internet radio companion for.
Yeah.
So up here, it's already be a step forward.
So.
Yeah, this is kind of.
I mean, it's text, yeah, but.
So
I think you would run into some problems. I'm trying to think of some off the top of my head. So you can see the data. It looks JSON-like. I mean, like I said, we're storing in MongoDB. But for those of you who are really upset, having a hard time making it. Oh man, I was hoping that was more of a joke. Okay, anyway. I think I'm just going to provide these resources. This whole slides, and if you actually want to see the demos, you can find them. I'll write it over here. Actually, I can probably just open it somewhere here. GitHub. NashJS, no hands. Yeah, there we go. So here we actually have the code that I was going to be showing as the examples, with a link to the slides, which has a link to the other slides, and all sorts of fun resources. So, you guys, does anyone have any questions? If they don't, we can eat more pizza and try to make up for,
You're
these.
fine. You did a good job.
somewhat clumsy parts of the presentation. All right.
So can we see the working example?
I hope. I would like to say yes, but can you give me a minute to check after, like when I'm not like on the spot? That sounds good. Actually, if you want, if people, okay, how many people are interested in that example? Ah, crap. I was gonna say you could just come to my computer if it wasn't a couple of you. You have it?
Yeah, it's fine.
Okay, thank you. Thank you, Hakan. Wanna trade?
Well, hopefully it's just, I mean,
I know I won't be able to screen share this part now, so it's for anyone who's using the Google Hangout or the video, go to the GitHub. All right. So in this example, okay, so as I showed before, we have this dependency graph. We have all these cool things. We can run up to this play button, click, and this will give us a list of the plugins that we defined for this model. We can click Run Query Dependencies. That's the plugin that I made. And then hit Save and Run. It will run, and that one pops up and shows the artifacts that are remaining here. And then I can click on Details, of course. And now what this tells you is the execution history, so it tells you the hashes that it ran on and the hash of the update. Again, referring to like the version control of your entire project. And then it will download this code, which I had to create, which I'll show you the plugin actually here in a second. So question, can I? Thank you. All right, so now I can take this, copy it, and I want to. Right now, I'm actually demonstrating how bad I am with Mac. So actually, we look really close. You should be able to see. I need to go back to the browser. Oh, there we go. I was trying 3-finger swipe, and I needed one more finger. I just didn't realize. Anyway, so now we take this prologue code. What's going on?
So you just stop doing that.
So much so. Yeah, pull it out. So we've seen like half of the example. Okay. Come on now. Okay. All right. Convert to JavaScript.
Yeah.
JS. Yeah, you can output whatever you want. Basically, any code that you have that you want, because you're essentially just generating text. So you have access to the model, so you can make whatever you need. All right, so now if I take that code that I just had and I try to paste it here, and I'm successful, which is fantastic, I can actually, so do any of you guys know Prolog? A little bit? Okay, so ignore the Prolog for now. Actually, I can explain it in a second. But if I say all dependencies, okay, in a nutshell, these are all rules. These say that the go on Ruby requires the Ocarina of Time, or maybe the other way around. Either way, so I have all these rules, and then I have a couple inference rules. It's a logical programming language. So then when I actually have this not quite interpreter shell thing running, I can type in questions, and it will tell me whether or not they're true or false, or it can be inferred from this collecting this knowledge base. Everyone understand? Everyone on the same page with that? You guys got it? Okay, so now if I ask all dependencies of Big Goron sword, it tells me I need the Bombay, the Boomerang, the Deku, the opponent's song, Fairy Ocarina, and all those fun things. Now, if I say I want all dependencies, which if we actually look back at our demo, you can see that that's the case because you need pretty much everything. At least everything that I showed here. Kokiri Sword, Deku Shield. It doesn't do the same order because again it backtracks and does weird algorithm stuff. Not gonna get into that. Anyway, But you can see that this actually generated a prologue that was able to infer what all the list of dependencies that I needed for my project. I could do the same thing with Ocarina. Huh. Not even that bad now. I feel like I was like keeping you guys forever. I had you for like an hour and 45 minutes. You guys thought you were gone. This is great. I probably had time to like fix problems, write an email. Okay, all dependencies for the Kokiri sort. So I tried to evaluate this. There are no dependencies. So in Prolog, that's giving me false. Because basically in Prolog, it's thinking, or the thinking is more like, what are all the answers that could possibly make this true? When there are none, it goes, well, then this statement must be false. You guys with me? You guys wanted to play Ocarina of Time? I really do. I'll win the big ones. All right. So anyway, you can see how you can generate this. You can generate output. But now the question is, how do I do it? And now we actually can talk a little about JavaScript. All right. So using someone else's computer with stuff that I don't know. I can fix my line. All right, there we go. Okay, thank you. All right. So using, I'm not trying to fill things. Okay, I just need to get to the rest of the project. Step Ranger. Okay, install it under, right? Okay, thanks. All right, so we're using Ranger here, which is like fantastic. I love it. Anyway, it's a file manager in the terminal. So anyway, this is the project. This is actually the source code for the app that I was using, that I was just showing you, that has a dependency graph for the Ocarina of Time. Now, if I look in source, I have a plugin in here, and the plugin, as if you remember, was called Query Dependencies. And now we can get into the source code. So when you create a plugin, most of this is boilerplate that's auto-generated for you. The meat of it, or the important stuff, is right here. We have a function called main, and the WebGME exposes this interface for interacting with the model called the core. It gives you access to the root. It lets you know about the root node and the active node, and then you have this guy that allows you to query. Yes, I just realized that if I'm having a hard time seeing it, you guys probably do too. So here so the active node would be this graph, this dependency graph that contains all these Zelda nodes, or these nodes about the items in Zelda. Now we can say using the core, we can. That's right. What's that? Oh, well, I'm using Vim, and it looks like Hakan also replaced his caps lock and escape key. So I was thinking, oh, I'm on someone else's computer. I have to hit escape, and then that was caps lock, so that's gross. Anyway, I am not quite as like awkward on the computer as I might seem. Anyway, so so using the core, we can load the children of the active node. So this is basically getting us all of these nodes. Now, if you remember in our Metamodel, the required for relationship was a node itself that had references. So that's actually the connections are treated also as nodes. So, because it's actually the visualizer that determines that these things are actually connections. Because if you wanted, you could make another visualizer which looks at that relationship and says, yeah, I realize that it's going to be a connection, but I want to show it as a separate node, or I want to show it as a square, or big bird, or something. Maybe a Kokoriso. Yeah. So what this code does here is first we get the connections. So we get all the children nodes of our active node, which are all those boxes and lines in that model. And then we filter these children by checking to see which ones are the meta type of this required for block. If we remember back here and click in the meta, we actually defined okay, so we have this required for relationship and items. So we can check to see what, this is basically checking the class, essentially. So we can get the meta, so this gives us all of the required for nodes, which are all the connections. And then for every one of the connections, we create this prolog rule, which, if we remember from here, can I zoom in? There we go. Each one of these lines actually corresponds to a connection in the model. So, because all those connections actually carry all the meaning that we need here, because those were connections define which one's a dependency of which other. Now, Prolog does all the heavy lifting here in actually chaining all of these together and figuring out what is the list of all the dependencies that I would need. So that's why I chose it. And it was kind of fun, but it ended up with a really small plugin, which is nice. So this just creates each one of those rules, and these rules just get the source and destination. So that at first I get the names of the box on both edges, or both ends. First the source and the destination. I convert them into the path, or kind of think of like the ID of the source and destination pointers or references. And then I map each of these IDs or node IDs to the actual nodes, which I have a dictionary of that I passed in. And then I get the name attribute from each of the nodes, and then I make sure that it's something that's Prolog friendly, so I make it lowercase and remove spaces, switch them with underscores. And then I use some fun ES6 stuff. It has some pretty nice stuff in ES6. Anyway, sorry. Where I create this requires statement and use it, basically it's a string template here, where or string interpolation, really, where I add the source name and the destination name in this requires string. I do this for each of the connections. And then I add a couple of extra rules that I need in order to be able to do the inference and actually chain it together. And then I just save the file, which all of the stuff down here is. And then I save the file, make it available, and set it as one of the results, and then we're all set. Or add it to the results. And then it makes it available for you to download. Are there any questions there, actually? No? Cool. Now, we can actually, this is great. It's nice when I can show my demos. Otherwise, I was just like, guys, trust me, it works. Although I'm demonstrating that it doesn't. But anyway. So I also made an add-on. So add-ons, like I mentioned before, are event triggered. So the add-on that I have here, actually I'll show you the code first, so you can figure out what it does. So it's called NameMaker. It imports a list of superhero names. I should probably come up with like a more useful example. But anyway, well, again, this is all generated. Like I just tweaked like 2 lines in here. Otherwise, it gives you all the boilerplate already. So the NameMaker. So on any update event, whenever the add-on's triggered, all I do is get some random superhero name, as you can see here. Superhero names, which is an array of names. Then I just grab a random one. Even though on a side note, the math.random apparently in JavaScript is pretty bad. So anyway, beside the point. Just saying. Use bcrypt. Okay, and then it'll actually change the root node's name to this value. So we can see this if we edit. So the root node is over here. See this caretaker? This caretaker node. So if I actually drag something here, it'll receive an. It should receive an update and should be changing. That breaks something else in this example. Am I not running this stuff? So add-ons actually need to be enabled. And I may not have enabled this one here. Use add-ons. All right, now. Oh, Hakan, what version of Node are you using? Who needs versions, right? Anyway, so I think I was using some string interpolation or some fun. Oh, I use string interpolation in them. What's that?
Use Babel
How come you probably don't have Babel installed?
It's not console log.
Oh yeah, because it's saying it's illegal, but it should. That's the string interpolation. Okay, so the easiest way to fix this is actually to just delete that line, because it's just a console log. But so if you use features that aren't in the version of the language that you're using, it's weird, but it doesn't always work. Strange. I don't know who makes these rules. Man, you are just like getting used to my bad jokes. Thank you.
I thought you had to let stand somewhere else.
Yeah, so it should have worked. I don't know why I was throwing an error with that one, but that was clearly a string interpolation problem.
Yeah.
So I was using those dashes.
You don't have Babel, then you have some other stuff.
That was working. Yeah, because even generating my prolog rules was using string interpolation. So it should have worked, but anyway. Okay, now if you notice, our root node rather than being caretaker is Samus, and now it's Juniper. So, okay, in my defense, I found these superhero names online. I know everyone's thinking, what kind of superhero names are these? Mental. I'm gonna try it. Anyway, so that was an example of the add-on and the plugin, and how like a basic plugin would work. If you guys want, I can do more things. Make a new project from scratch. Find me on live, jump through hoops. Good. At the mercy of the people here. Anyway, are there any questions? Because now I have examples and cool things. Questions? All right, if there are no questions, I'll probably just adjourn us. Oh, do you guys want to see cool examples? Oh, things is going to end poorly. I will try. Oh, are you guys interested in more examples with things?
Yes.
All right. So I'm going to clone the. So if you remember earlier, I mentioned that. Also another fun fact: the WebGME has a nice command-line Rails-like interface. So when you want a new plugin, you just say new plugin. It generates a boilerplate, takes care of all that stuff for you. You can add dependencies from other GitHub repos and just import them. It has support for plugins, seeds, all sorts of fancy things, layouts, visualizers, some things that I didn't get into in the presentation. But
is the other stage using this or is it HTML and CSS?
So it's all HTML and CSS at the core. You can change pretty much whatever you want. So it's very flexible. I'm going to show you actually a new. As soon as this guy installs, I have an example of the visual editor, or the development environment for deep learning. I figured I'd throw some of that up here. We have some kind of cool things there. I'm actually using the executor framework there to actually train convolutional neural net models, which is fun. But now we can compile C. So does anyone know any good jokes? Oh my goodness. I am not going to quit my day job.
It was a mollusk and a cucumber.
No one else likes Finding Nemo? Right. See cucumber? Wait, is that right? That's why I said it. All right. All right. Now let's create a new cafe. Cafe is a Berkeley thing. Don't worry about it. So right now I'm more tightly coupled to the back end than I'd like to be, but I figure it's a good starting point. Linnet is a pretty well-known, I guess, ConvNet architecture. Now what's going on here? So are you guys? So if you're not interested in this, well,
Let's talk about this.
You're really interested? Okay. Sounds good. Okay, so this one, things are going to be changing here a bit. I'm actually working on a whole new visualizer for this because there's this concept in model integrated computing called correct by construction, which means the way that you wrote it means that whatever you wrote must be right. It's a pretty cool idea. There's a lot of people there, right? Man, we're awesome. Anyway, so the idea is that like, it restricts the search space, or like the development space, so to speak, of what's valid or what can actually be made with your tool to only the things that are valid. Now, this doesn't have that there yet, but it will in like, I don't know, 2 weeks or something. Anyway,